Sure.
All right, so we are visiting with Darlene Bos, the interpreter ranger here at Yellowstone. She's going to talk to us now a bit about the aquifer that sits underneath this amazing park.
So where all of us live, we have aquifers. Essentially, there's the ground water comes in the form of rain, in the form of snow melt. It drips down through the ground and into essentially a large cavern in the rock. And that cavern has water in it that's generally pretty cool. A lot of us can drill a well into that, and it might be in 40 degrees or so. It's pretty cool water when we pull it up. And fresh water, generally. It might have some things that's leached out from the rock, but in general, it's pretty fresh water that's coming from the ground. Now, here in Yellowstone, we have an aquifer too, just like everywhere else. Our aquifer sits on top of a giant volcano, however, and it sits on top of a plume of magma that is between 2 and 6 feet beneath us. So this plume of magma is creating miles. Thank you. 2 to 6 miles. Let's try that again. 2 to 6 feet would be really concerning.
Pretty close. We might
I would be worried about that. 2 to 6 miles beneath us is this plume of magma. And what it does is it creates an enormous amount of heat. Magma is 4,700 degree molten rock. And so that heat can even sometimes come up to the surface. Sometimes you can feel it in places on the ground, 104, 105 degrees, just on the surface of the ground. And so as a consequence, what it does is it heats up that aquifer. So that aquifer is 400 degree water. How is that possible? 400 degree liquid water? Well, pressure. Pressure does that. It's just like the boiling point changes when we go up in elevation. If you're at sea level, if you're in northern Minnesota, the boiling point is 212 degrees. But if you're here at Old Faithful, which is at 7,360 feet above sea level, you end up with a boiling point of about 198 degrees. And that's because there's less pressure from up above, and so the boiling point basically lowers. Same thing happens in reverse when you go down under the ground. Pressure from the rock and the soil goes on top of that and makes the boiling point rise. So we have 400 degree liquid water down in this aquifer. And then it comes out in the form of hot springs, geysers, and other thermal features. When it gets to the surface, naturally steam is created. When a geyser comes out, we end up with an eruption because we end up with pressure inside of that system. And so our water, instead of coming out in the form of a well that we drill, which we don't want to do in Yellowstone, instead what we end up with are all these cracks and fissures, and that water comes back up from the aquifer through the cracks and fissures. So Old Faithful, for example, has a crack in the earth, and all that water comes up through the crack in the earth. And about 22 feet beneath the surface of Old Faithful, which you can see here, there's a constriction inside of it. And that's where the water gets stuck. And then an eruption happens because of that constriction. So that constriction is essentially what makes a geyser as opposed to a hot spring. Hot springs have a normal flow up and down convection that occurs inside of there, so they don't have a constriction. And so all this water is coming down in the form of rain and snow into that hot aquifer. It's heating up, and then it's coming back up to the surface through all these cracks and fissures. Cracks and fissures got there because of all of our earthquakes. 2,000 to 3,000 earthquakes a year that happen in Yellowstone. So the earth is constantly cracking, and the water finds all these places to come up to the surface. So we end up with this cycle of water that comes in and out.
It's a full circle.
A full circle, exactly, exactly.
And what is the danger if people were tapping in to this aquifer and to this geothermal field? What would happen?
Great question. Well, the concern is that it would shift that water and we would no longer have the geyser and hot spring activity that we do. In essence, it would alter that activity. So geothermal energy is not something we use in Yellowstone. The park is protected from it, and that is because of the concern for what it would do to these geysers, these hot springs, and these thermal features. It would change them because you're taking that water that's being used by these aquifers. In fact, there's a geyser up on top of that hill. It's called Solitary Geyser, and it used to be a quiet little hot spring. And it was pretty full of water, and one day they decided to pipe the water down. Now this was early in the park's history, and they piped it all the way down that hill, and they created a bathhouse from it. And what happened subsequently was that the water level was lowered in that feature, and it actually is a geyser today, and spouts occasionally.
So where does all the buildings here, where do you get your water?
We have
Drinking
water treatment facilities, and rather than using the water that is connected here to our thermal features, they use other sources of water that they then treat through water treatment.
So
for
like the rivers
people.
or?
It depends on where you are in the park. In different locations, different surface waters, natural springs that aren't thermal, things like that. It all depends on where you are in the park. Each water treatment facility gets their water from a different location.
I see.
We have them throughout the park.
Okay. Well, thank you, Darlene. This has really been great, and
Wonderful.
we're glad you could share this information with us.
Thanks.